So now we will look at the production possibility frontier of this specific factor model. And the production possibility frontier looks a little bit complicated, but it's easy. So don't worry about the graph, but we'll talk about 4 quadrant diagram for the possibility of production in a specific factor model. So the 4 quadrant looks like this one. So here, this shows the allocation of labor, okay, this quadrant, and this shows combination of production for clothes and food, and this shows the production of function of clothes, production function of food, then this is the economic distribution. So this is our production possibility frontier, okay, for specific factor model. But we use this 4 quadrants to produce this production possibility frontier for a specific factor model, okay? So we have 4 quadrants. We have the quadrant at the left below shows allocation of labor, where we have a linear, okay? So the relationship between these 2, labor input in food and labor input in clothes, is linear. Then from this we will derive the production function for food, production function for clothes, and we will also derive the economy's possibility, production possibility frontier for both food and clothes, okay? So this shows the production possibility for both food production and clothes production, okay? So I will start with this one here, the allocation of labor, okay? So from here we draw the production possibility frontier in the specific factor model. So this one, the first one, is simple, okay? So here, this is for labor to produce food, and this is the labor to produce clothes. As we have said, when we use more labor for clothes, we produce more clothes, and when we use more labor for food, we produce more food, right? So with zero labor for food, we produce this much amount of clothes, okay? With zero labor for clothes, we produce this much food, okay? So when we produce less here, less labor, then that means that we use more for clothes, okay? You can see that here, 0 clothes, this much labor for food, okay? So a little bit lower, decreasing the labor from food and using it to clothes will produce, okay? So at this point, we have this here, and this side, this much, okay? So when we decrease the labor force in food by this much, we increase the production of clothes by this much, okay? When we further decrease the labor in food by this, then this means we have this point at this point, okay? So we increase the productivity of labor to this point, okay? And further, when we decrease the labor in food here, we produce more of clothes here, right? So this shows a linear relationship between labor employed and productivity in each of the goods. Okay, so more labor, more of the product production. So when more labor is used for food, more production of food will be there, and when more labor is used for for clothes, and more production of clothes will be there. Okay, so this is a linear relationship between these two. Okay, so from here, for example, when the labor is decreased to this point, okay, when labor amount decreased from this to this, then the equivalent point in the production possibility frontier will be here, right? And production possibility quantity will be here, okay? And again, at this point, we have this much close, and it is this much production possibility frontier for close. Okay, so this is the production capacity, production possibility frontier for clothes, and this is production function for food. Okay, so when you further decrease the labor to the here 0.2, then this is the labor, and this is the production capacity for clothes, and this is the production capacity for food. Okay, and when you take this further here and this point here, this will be the quantity of food and clothes that a company can produce. Okay. Again, going further to point 3, where you have this much amount of food and this much amount of labor for clothes, then you will have this amount of food produced and this amount of clothes produced. Okay. Then this goes to this point, and this goes to this point, goes to here. Okay, so finally, when you draw the production possibility frontier like this, and this is a production function for food, and this is a production function for labor. Okay, so it all starts from this real linear relationship, and from this linear relationship between food and clothes, we draw the production function of food, production function of clothes, and finally, from this production function of clothes and food, we produce this economist production possibility frontier of both quantity of food and quantity of clothes. Okay, so I will explain this one more time. So let's start from the beginning. Okay, so you start from this allocation of labor, this linear relationship between food and clothes. Okay, as we have said, when you produce 0 clothes, you produce this much amount of food, or when you use all the labor to produce food. Okay, as I've said, if you have, for example, 100 labor, when you use 0 labor for clothes, then you use 100 labor for food, right? When you use 10 labor for clothes, you use 90 labor for food. When you use 20 for clothes, you use the rest 80 for food. Okay, so that gives us this linear relationship between the labor required in food and the labor required in clothes. Okay, so that's why this linear relationship happens. Okay, so from this linear relationship, when you decrease the labor from food by this amount, that means you are increasing the labor amount for clothes from 0 to this, because at this point you have this intersection. Okay, so this is the amount of clothes for, the amount of labor for clothes. And when you take away this amount of labor from food, this means this point intersects with this one and this one. So this means now you are using this amount of labor for clothes. then it goes to this point. Okay, so when you decrease the number of labor for food to 0.3, then it intersects here at this point. So now it means that you are using this amount of labor for clothes. Okay, so with this number of food and clothes, okay, with this amount of labor and labor for food and clothes, then you produce this amount of food. Okay, and for this amount of labor for food and clothes, you produce this amount of clothes. Okay, and point two, for this amount of labor for food, this is the amount of food you can produce, and this is the amount of clothes you can produce. Okay, you can see when this decreases, this increases, right? Then at the third point, when you have this amount of labor for food, then you produce this amount of food, then you produce this amount of clothes. Okay, then from this point you can draw, okay, this intersects here, okay, because it is this one, right? And the second one is this one. So this amount of food, the production possibility frontier goes here because you have this amount of labor, I mean this amount of clothes production. And for this amount of food production, you have this amount of clothes production. Then when you finally connect this point, it comes like this, okay? So it is not a linear relationship, but it is a curved relationship which shows the production possibility frontier for specific factor model. So finally, this is our specific, our production possibility frontier for specific factor model. Okay, so it is dependent on this simple assumption that when you use more labor for food, you produce more food. When you use more labor for clothes, you produce more clothes. But this is the point where it comes, you can produce a mix of these two, food and clothes, okay? This quantity. So this is derived from this three graph. So this four quadrant graph shows the production possibility in the specific factor model. So I hope it is clear. So why is the production possibility frontier curved? Okay, we talked about the diminishing marginal product. Okay, so we have said there comes a point where you increase the labor and the capital is constant. So it results that the 1 unit of labor you input into the production will produce less productivity as compared to the previous labor that you have added to the production. Okay, so the reason why it is curved is the diminishing returns to labor in each sector cause the opportunity cost to rise, okay, when the economy produces more of a good. Okay, and when opportunity costs rise, it's not even feasible to produce that product. Okay, because we have said the the opportunity cost has to be lower, right? So it's curved because the the opportunity cost started to increase. Okay, so opportunity cost of clothes in terms of food and the slope of the production possibility frontier, the slope becomes steeper as the economy produces more clothes. Okay, so steeper means it gets to straight line. Okay, so for example, here you have this graph. This let me remove this and show you the slope. Okay, so the slope here, you can see, let me draw this. This is the slope, right? So this point is the slope at this production level. But you can see, for example, this is the slope at this production level. So if you compare these two, this one and this one is steeper, okay? No, as compared to this one. So it's not flat like this. So when you produce more of food and less of clothes, then the slope becomes steeper and steeper, okay? Because when, for example, if the graph is like this, it means that you are producing more of this, okay? And less of this. And when the graph looks like this, it means that you're producing more of this and less of this, okay? So the opportunity cost of clothes in terms of food in the slope is the slope of production possibility frontier, and the slope becomes steeper as the economy produce more of clothes, okay? Then opportunity cost of producing one more yard of clothes, that is this, okay? So in the previous chapter, we have seen how to calculate the opportunity cost. So in this, if this marginal diminishing of product of food is greater than this one, then you should produce less food, right? And if this is MPLF is less than this, then you can produce more of clothes. So this is our slope. So to produce one more yard of clothes, then you need 1 over the marginal product of labor for clothes hours of labor, okay? So to free up 1 hour of labor, you must reduce the output of food by this amount of pounds. Okay, so to produce less food and more clothes, employ less food and more in clothes. Okay, that's clear, right? If we want to produce less food, then we employ more of the labor to production of clothes, right? So employ less in food and more in clothes if we want to produce less food than clothes. So the marginal product of labor in food rises and the marginal product of labor in clothes falls. So this will rise the slope, okay? So now let's talk about the price, wage, and labor allocation. So how much labor is employed in each sector? We need to look at supply and demand in the labor market, okay? So now we consider the price, and in previous chapter, we also looked at the change in price and the change in allocation of each of the products in production, right? So we look at the demand and supply in the market, okay? So demand for labor in each sector, employers will maximize profits by demanding labor up to the point where the value produced by additional hours of the labor equals the marginal cost of employing a worker for that hour, okay? So this means this demand talks about consumption, okay? So we will produce more of clothes and we will use more of labor to produce this clothes as long as the marginal cost of adding 1 more unit of labor to the production is not greater than the profit that we get from producing this more products, okay? So if increasing or adding 5 more units of labor has a cost of $50, and increasing this 5 units of labor has created more production that has resulted in the profit of $60, then we keep on adding labor. But if this addition of 5 units of labor to the production costs us $50 and the production of this clothes costs us only, gets a profit of only $40, then this means that the marginal cost of employing more unit of labor has resulted in more cost than profit. So at this point, we have to stop, okay? Because if we keep on adding more labor, which results in more marginal cost than profit, then we will keep on losing money, okay? So just increasing labor will not result always in profit. You have to look at the marginal cost of adding this more unit of labor to the production. So the demand curve, okay, for labor in the closed sector is equal to the marginal product of labor times the price is equal to wage. If you remember, in the Ricardian model, since we were not using labor or capital as a means of production, we were saying that wage is equal to the price of cheese and wage is equal to the price of wine, okay? But now we have additional factor of production, which is labor. That's why, and in labor, we consider the marginal product, okay? Because we have said that at some point, increasing the labor might result in a lower profitability. So that's why we consider the marginal product of labor in clothes times the price of clothes will be equal to wage. So this, it is clear that as long as this is equal to wage or this is higher than we produce, okay? So this is the equation for demand curve. So the wage equals the value of the marginal product of labor in the manufacturing, and in the same way, the wage is equal to the marginal product of labor in food, okay? So now the figure 4 below will represent labor demand in the two sectors. So the demand for labor in the clothes sector is represented by this marginal product labor of clothes from figure 4.2 multiplied by the price of the clothes. The demand for labor in food sector is measured on the right, which is the horizontal axis represents the total labor required to produce both these products, okay? We will look at this one. So the two sectors must pay the same wage because labor can move between sectors. As we have said, labor is mobile, okay? So mobile in a sense, we can use or we can move some labor from food and use it for production of clothes, okay? So you just assume that in South Korea, we have a company and that company only produces clothes and food. And to produce clothes and food, we have we have labor, we have capital, and we have land. And we are keeping capital and land fixed, okay, or specific, and we are using labor, or we are moving labor between these two production, and we are trying to see which units of labor has to be used for food and which amount of labor units has to be used for clothes, so that we can produce the optimal amount of food and clothes to make a higher profit, okay? So if the wage were higher in clothes sector, workers would move from making food to making clothes until the wages become equal, okay? So we have here a food production, we have here a clothes production, okay? So if the amount of wage paid for the workers in the food production is high as compared to the amount of wage that is paid for workers in clothes production, so workers in clothes production will move to the food production company, okay, or the food production sector. And they will go there until the wages paid here in food production are equal to the wages paid in close production. Okay, that's obvious. Or if the wage were higher in food sector, workers would move from the close to food, food to close. Okay, so where the labor demand curve intersect gives the equilibrium wage and allocation of labor between two sectors. So which one is the equilibrium wage where there will no more movement of labor between these two sectors? Okay, so I will just try to remind you of the demand and supply curve I showed you last time. We have said that this is the demand curve, and the demand curve shows that when price increases, okay, demand decreases, okay, and when price decreases, demand increases. Okay, that is natural. So you can see the point here. For example, if the price is here, the demand for this product will be here, and if the price, for example, decrease to here, okay, the demand for this product will be here, right? So demand increases as price decreases. Okay, and I have showed you the supply curve. Okay, supply curve looks like this one. So the supply curve tells us that as price increases, supply of this product increases. Okay, so when a price of a product in the market increase, more suppliers will produce this product. Okay, but this is the price, as you have said last time. So the point where the supply and the demand meet is the price of the product that with which the farm producing this product and also the customers buying this product are happy. Okay, so which means a farm cannot charge the customer above this price, because if they charge above this price, the customers will move to buy other products or other similar products. Okay, so this is called the equilibrium price. Just like this one, we have the equilibrium wage here. Okay, so in this graph, you can see that we have the value of labor's marginal product wage rate. So actually, it's not written here, so I want you to write this on the right side of the graph. So this is value of marginal product of food, okay, and that is the wage rate. Okay, so this one, the red curve is for this one, and the blue curve is for this one. Okay, so as we've said, when you increase, so here you can see this is the labor, the x-axis is labor, right? So when you increase labor for production of clothes here, then the marginal product of clothes here decreases. Okay, so we have this, we have already seen this graph in previous slides. Okay, the same thing is true for the marginal product of food, where you have more labor, then the marginal product starts to decrease. Okay, so when these two intersect, this is a point where the wage is called the equilibrium wage. Okay, where these 2 points, where P, C times or multiplied by marginal product of labor of clothes is equal to P F times the marginal product for labor. Okay, so this is the equilibrium wage, or the point at which these two become equal. Okay, so this is the total labor used, because labor used in clothes we have here, and labor used for food. So value of labors you can use in quotation here clothes. Okay, so this one is for clothes and this one is for food. So this is the equilibrium wage where both the price of clothes and marginal product of clothes is equal to price of food and marginal product of food. Okay. Okay, let's continue. So this is the total supply of labor we have. So at the production point, the production possibility frontier must be tangent to a line whose slope is minus the price of clothes divided by that of food. So the relationship between the relative price and output looks like this. You can take price to the, so you can, from this, you can compute, or you can take this one here, and you can compute the slope. Okay, so here this is the slope where the quantity, for example, the quantity of food is this much, the quantity of clothes production is this much. So this is the point where this two meet. Then this is a tangent line to the curved graph or to the production possibility frontier of the specific factor model, and this is the slope, right? So the slope is PC over PF, then it's negative, right? So just like we compute for the slope in previous chapter, it's the same way we compute the price. I mean the slope for specific factor model. Okay. Okay, then what happens to the allocation of labor and the distribution of income when the prices of food and clothes change? So now in previous slides, we were talking about labor mobility, right? So now what if the price of food and clothes change? So how would that look like, okay? Or how much proportion of food or how much proportion of clothes we should produce. So there are two cases: unequal proportion change in prices and a change in relative prices. So last chapter we talked about relative prices. So in a closed economy, you don't have to look at relative price. Okay, so closed economy means a country that doesn't export. Okay, so products are produced within Korea and consumed within Korea, then we say this is a closed economy, right? But when you get involved in international trade, then it's no more closed, right? So you have to consider the relative prices of your products, okay? And this will result in relative demand and relative supply, as we have discussed last week. Okay, so when both prices change in the same proportion, okay, no real change occur. So if the price of clothes increased by 10% and price of food increased by 10%, okay, so the wage will increase with the same percentage, 10%, okay. The change will be seen only when there is a disparity between the percentage change in this clothes or food and percentage change in one of these productions. So the wage rate rises in the same proportion as the prices. So real wage, that is the ratio of the wage rate to the prices of goods, are unaffected when there is equal change. The real income of capital owners and landlords remains the same. Okay, but this, so this, you can look at this one. Okay, this was the original graph. Okay, this is the original graph. We have this too for production of clothes and production of food. Okay, as we have seen in the previous graph. So what if we increase both by 10%. 10% increase in production of clothes will move the graph to the right, right? And 10% increase, so you can use the same thing here, value of marginal product of food, okay? So when we increase the percentage by 10, product price of food by 10%, then the graph will move to the right, okay? So this moves here, okay? And this graph moves here. So now we have a new equilibrium wage. Okay, it was previously here, now it is here. Okay, so if you see the difference here, okay, it was here, then the wage increased to this point, and this wage increase is the same, 10%. Okay, so when the increase in price in both of this production in clothes and food is the same percentage, so the change in wage will be the same. So the problem comes, or the real effect comes, when we increase the price of clothes, for example, by 5%, and do not increase the price of food, or increase the price of food with a different percentage. Okay, so now there is a disparity between percentage of increase in clothes and percentage of increase in price in food. So now the wage increase will be different. Okay, and some, not both, will be benefiting from this. Okay, so let's see. When only price of clothes rises, labor shifts from the food sector to the clothes sector. Why? Because we have said that workers will always go to a company that pays more, right? And if price increases, this means wage increases, right? Because we have said that marginal product of clothes times the price is equal to wage in a specific factor model, right? So if price increases, this means wage increases. And if wage increases, this means that the labor unit who used to work in clothes now will move to, labor unit who used to work in food now will move to the clothes production, because now clothes production pays more because they earn more wages. Okay, so when only price of clothes rises, labor shifts from food sector to clothes sector, and output of clothes rise while that of food falls. That is clear, I guess, right? There were units of labor here and units of labor here in clothes. And we have said that we increased the price of clothes. And when you increase the price of clothes, the wage increases. When wage increases, more laborers will be interested to work here. So those who used to work in the food, now in the food sector, now will move to the clothes sector because they pay more, right? So this means now more clothes will be produced and less food will be produced, right? So the wage rate does not rise as much as the price of C, since close employment increases and the marginal product of labor in that sector falls. Okay, so this means that if we increase price of clothes by 10%, it doesn't mean, okay, it doesn't mean that wage will increase.